In this lecture, we are going to discuss about the electron configuration. Electron configuration is basically the word configuration mean an arrangement. So we will discuss that how electrons are arranged in energy level inside the atom. The student, as you know that atom consists of a nucleus, and a nucleus is basically consists of a positively charged particle, protons and neutron. Around the nucleus there are energy levels. First energy level around the nucleus is known as K shell. Second energy level around the nucleus of an atom is known as L shell. Third energy level around the nucleus is known as M shell, whereas fourth energy level around the nucleus is known as N shell. So the electron in in an atom are basically placed in these K, L, M, N energy levels. Student, please keep in mind that every shell has subshells. Like K shell have a subshell, it is known as 1s2 subshells. Similarly, L shell has two subshells. These subshells are known as 2s2, 2p6 subshell. M shell have three subshells. These are 3s2, 3p6 and 3d10 subshells. Similarly, N shell have four subshells. These subshells are known as 4s2, 4p6, 4d10 and 4f14. So the student, first shell, which is known as K shell, has one subshell. Okay, M shell has two subshells, N has three subshells, N has four subshells, and O shell will have five subshells, and so on. Every subshell in atom subshell in atom have further uh, orbitals, and these orbitals are present inside the subshells, and these orbitals basically occupy the electron in spin up and spin down state. So, dear student, please keep in mind that orbital in an atom can occupy electron in spin up, and as well as spin up and as well as spin down state. So, electrons present in an in orbitals are either in spin up. Sorry, this is spin down. So, are either present in spin up or spin down states. So there is a possibility for electron to be present either in spin up or in spin down state, or they may be present in orbital. There may be one electron present in orbital, and that could be in spin up or spin down state. The student, interesting point here to notice is that it the orbitals are more stable when the electrons are present in a form of a pair. Unoccupied orbitals are not stable, whereas the occupied orbitals are more stable than the unoccupied orbitals. So now let us discuss that how how much orbitals are present in sub energy levels. As you know that the subshell first the K shell has one subshell, and that subshell is known as 1s2. So the K shell has only one subshell and it has only one orbital, okay, one orbital. And if this one orbital of the K shell may have one or two electron, and these electrons may be present in spin up or spin down state. Similarly, L shell is a second shell. It has two orbitals, and these orbitals are it has two subshells. These subshells are 2s2 and 2p6. So the S shell has a capacity to accommodate S subshell has a capacity to accommodate two electron, and orbit can also accommodate as a maximum capacity of accommodating the two electrons. So this the S orbit of L shell, it will be S subshell of L shell will have only one orbit, okay, it will have one orbital, and the arrangement of electron may be in the form of spin up or spin down or in the form of pair, whereas the P shell of P shell of the P subshell of L shell will have three orbitals. The reason of three orbital is that the orbital can accommodate only two electron in it, whereas the maximum amount of electron in P subshell of L shell is 6. So the electron are 6. This means that 6 pairs, there will be 3 pairs of electron possible. 3 pair of opposite spin of electrons are possible in the P subshell. So that is the reason there will be 3 orbitals in uh, P subshell of the L shell. Similarly, if we consider M shell, M shell, as we know that it has three subshells. These subshells are 3s2, 3p6, 3d10. So the 3s2 shall have ability of 2 electrons, so it will have only one orbital, and the arrangement of electron will be either in spin up or spin down state. And 3p as has p has a 3 the 3p subshell has has 6 electrons, okay, it has 6 electrons. So there will three orbitals to accommodate the 6 electrons. So there will be 3 orbitals. The electrons arrangement will be in spin up or spin down state in 3 orbitals like this. Similarly, if we consider the 3d10 subshell of the atom, it has 10 electrons in it. It has a maximum ability to accommodate 10 electrons. So this subshell will have 5 orbitals. 1 2 3 4 1 2 3 4 5 orbitals in order to fill or in order to complete the 3d subshells. So these 10 electrons will be in a form of spin up or a spin down state, or they may be present in a form of a pair in spin up and spin down state. Okay, so this will be arrangement for the electrons present in M shell of the an atom. In order to in case of O shell has in order to for in case of N shell, Mn. So in order to N shell has basically 4 orbitals, 4 subshells. So 4s2, 4 p6, 4d10, 10 4f14 will be basically the subshell present inside the inside the n shell of an atom. So in this case, the s shell has only two electrons, so has ability to accommodate two electrons. So there will be only one orbital of inside the s shell, and it will have pair of electron like this. Whereas the p shell has six electrons, so there will be three orbitals in a p subshell, and electron will be arranged in the form of pair like this in three subshells, three orbitals of the uh, p subshells. In case of d subshell, there are 10 electrons, so this means that d subshell will be have a 5 1 2 3 1 2 3 4 5, so it will have five uh, uh, five orbitals, and these orbitals will have ability to accommodate maximum 10 electrons, 5 pairs of electron inside it. So the arrangement of electron in form of spin up and spin down state will be like this. In case of for F14 subshell, there will be, as you know, that the electrons are 14 in 4f14, so there will be 7 orbitals, 1 2 3 4 5 6 and 7, 1 2 3 4 5 6 7, 7 orbitals, and these orbitals will have electron in spin up and spin down state. Spin up, spin down, spin up, spin down, spin up, spin down, spin up, spin down state, spin up, spin down state, spin up, and spin down state. So in this way, electrons, the sub-energy level are basically filled inside the shell of an atom. So if I conclude, basically K shell has, dear student, K shell has only one subshell, and that subshell is known as S2 subshell. S2 subshell has ability to accommodate two electrons, so there is only one orbital present in S shell, and because every orbital has ability to accommodate two electrons, so there will be only one orbital in S shell. In case of L shell, there are two subshells, 2s2 and 2p6, and an S shell will accommodate two electrons, whereas P subshell has six electrons, so there will be three orbitals in P shell to accommodate the six electrons. In case of M shell, there are three subshells. These subshells are 3s2, 3p6, and 3d10s. S shell subshell has the ability to accommodate two electrons in its one orbit, whereas P shell will accommodate six electrons in its three orbit, and D shell will basically accommodate 10 electrons in five orbits in the form of a pair. In case of in case of uh, N shell, there are basically four subshells. These subshells are 4s2, 4p6, 410, 4f14. The 4s2 shell will fill basically two electron in its one shell, in its one orbital, whereas 4p6 subshell will basically fill six electron in its three orbitals, whereas a 4d10 subshell has basically 10 electrons, so it will accommodate 10 electron in its five orbital, whereas 4f14 subshells has 14 electron, so it will accommodate 14 electron in its seven orbitals. So now, question here arises is that the student, that how we will know that how the electrons will basically accommodate subshells on the basis of priority. How they will accommodate, in what way they will accommodate subshells. Basically, there are two main rules used for electronic configuration. One rule is known as Aufbau principle, and second rule is known as N plus L rule. Dear student, please keep in mind that Aufbau principle tell us that electron will fill low energy level or subshell first. So Aufbau principle tell us that electron will fill no low energy level or subshell first, and after filling the low energy level, electron will go slightly toward the high energy levels. From low energy level, this means that from low energy level energy, electron will go toward the high energy level. So this means that electron will initially fill the low energy level, and then it will start to increase the filling ability, and it will go from low toward the high energy levels. So now question here arises is that how we will know that which energy level has high energy. So for this, N plus L rule, N plus L rule is used. N plus L rule tell us about the energy of the energy levels. Energy of the energy levels are subshells. If N plus L value is high, this means energy of subshell is high. N is basically is a principal quantum number, whereas L is azimuthal quantum number. So we will basically determine the value of principal quantum number and azimuthal quantum number, and on the basis of the value of the principal quantum number and azimuthal quantum number, we can determine the energy of subshells. Dear students, since you know that there are different types of subshells in atom, these subshells are 1s2, 2s2, 3 sorry 3 2 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14. So now, dear student, how we can determine that which orbit which subshell has higher energy than the other subshells? For this, we will use N plus L rule. So now let us determine the energy of different types of orbital. So when we basically determine the energy of orbital, so then we can conclude that from no energy level to high energy level, electron will occupy the subshells of an atom. Initially, electron will occupy low energy level and then it will go toward the high energy levels. So now for this, let's start the calculate the value of n plus L. So we have s orbital, 1 s orbital, 1s2. We have 2s2 orbital, 2p6, sorry, 2p6 subshells, 3s2 subshell, 3p6 subshell, 3d10 subshell, 4s2 subshell, and 4p6 subshell, and so on. Okay. Please keep in mind, student, that for azimuthal quantum number for s orbit is value of azimuthal quantum value of L is 0. For p orbit, azimuthal quantum number value is 1. For d orbit, value of azimuthal quantum number is 2. And for f, the value f subshell, the value of azimuthal quantum number is 3. And whereas the 1, 2, 2, 3, 3, 3, 4, and 5 are basically, they are the value of principal quantum numbers. So for 1 plus L, 1 s square orbit, the value of n plus L will be, since you know that principal quantum number is 1, whereas azimuthal quantum number for s is 0. Similarly, for 2s, principal quantum number is true, azimuthal quantum number is 0. 2p6, principal quantum number is 2. For p, azimuthal quantum number is 1. For 3s2, principal quantum number is 3. And whereas the value of azimuthal quantum number for s is 0. 3p6, the 3 is principal quantum number, and the value of azimuthal quantum number p is 1. Similarly, the value of principal quantum number 3d in 3d10 is 3, and the value of principal quantum number for d is basically azimuthal quantum number is basically 2. The principal quantum number for 4s2 is 4, and azimuthal quantum number for s is 0. Principal quantum number for 4p6 is basically 4 as principal quantum number, and for p, the value of azimuthal quantum number is 1. This means that 1s2 has n plus n1, whereas 2s2 has 2, and 2p6 has n plus L3, 3s2 has n plus L3, 3p6 has n plus L4, and 3d10 has n plus L5, 4s2 has n plus L4, and 4p6 has n plus L5. So this means that 1s2 has the lowest energy, so electron will initially fill 1s2. Then n plus L2s2 has value 2, so electron will then fill 2s2 subshell. Now, question here is that 2p6 and 3s2 has 2p6 and 3s2 has same values like 3, 3. So in such cases, the value of electron, or the value of the energy, will be more where the principal quantum number is more. So this means that we will first write the energy of 2p6 will be less than the 3s2, because the value of n for 3s2 is more than the 2p6. So we can write this, that here it will be 2p6, and then we will write 3s2. Now the value of 3p6 and 4s2. N plus L value of 3p6 and 4s2 is same. So we and as you know that the value of principal quantum number of 3p is less than 4s, so this means that 3p6 has less energy than 4s2. So we will write 3p6 and then we will write 4s2. Now again the value of 3d10, n plus L value of 3d10 is equal to 4p6. Now again we the principal quantum number of 4p6 is more than 3d10, so we will first write 3d10 and then we will write 4p6. So in this way, increase in energy order, electron will fill or occupy the subshell of an atom. So we can use also trick to understand that how electron basically will fill the sub energy level. It is for that this, in order to understand the energy of subshells, we need to use the n plus L rule. However, in a simple way we can understand by using a specific trick. On the basis of that we can basically understand that which energy level will be filled in first and then next energy level will fill. The trick is like this. The student, in order to electron to accommodate the sub energy level, we need to know the energy of sub level energy levels, and the energy of sub energy levels or subshells are determined on the basis of n plus L rule and as well as Aufbau principle. However, in order to make it easy that the electronic configuration and energy of subshells, we can basically use a specific type of trick. Dear student, just write the sub energy levels. Like sub energy levels are initial, first sub energy level is 1s2, second one is 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14. Similarly, fifth energy level is basically 5s2, 5p, 5d, 5f, and 14 and so on. Okay. 5p6, 5d10. So now just draw a line, this type of line. Draw the second line. Line basically indicate that 1s2 has lower energy. The second line indicate that 2s2 has lower energy. Draw the third line is indicate that 2p6 has lower energy than 3s2, and then draw this line indicate that 3p6 has lower energy than 4s2. Similarly, draw this line to indicate that 3d10 has a lower energy than 3p6. So we can write this like this. Initially, first line is on 1s2, so we can write 1s2, 2s2, 3p6, 3s2, 3p6, 4s2, 3d10, 4p 4p6, and 5s2. So this means that energy of 1s2 is less than 2s2, 2s2 energy is less than 2p6, and 2p6 energy is less than 3s2. So this is basically very easy trick in order to understand that how and the electrons will basically in electronic configuration which energy level will be filled first. 1s2 has lower energy. This means that electron will initially fill 1s2 energy level or 1s2 subshell. Then electrons will fill 2s2 subshell, then 3p6 subshell, then 3s2 subshell, and so on. So, and the filling of electron or the filling of the atom will be done on the basis of the energy of the subshells. The energy of subshell we can determine in either by n plus L rule or by Aufbau principle, or we can use this simple trick for which will determine the energy of electron. The electron will fill lower energy, and it then will go from lower to higher energy, and in this way the structure of an atom will be completed by electron by filling its subshells or sub energy levels. So now let us do some electronic configuration for elements from having an atomic number from 1 to 13. So there are some elements where there are some exceptions in filling energy levels. So we will discuss those exceptions.